Hello everyone. We hope all of you are safe and fine. Today we'll discuss about the chapter 1 rational numbers. Rational numbers is an part of the number system. So first of all we will discuss about the number system. So in number system it starts from the natural numbers. Natural numbers is denoted by the and and it include numbers 1, 2, 3, 4, 5, 6, infinitely many of that numbers. The next group is an whole numbers. Whole number is denoted by the W. It includes 0 and 1, 2, 3, 4, 5, 6. That means 0 and natural numbers, which become a group of whole number. Then next group is an integers. Integers is denoted by I. In integer it includes the 0, natural number and negative numbers like -1, -2, -3, -80, -90, whatever type of minus number. But it cannot include the decimal numbers and fraction numbers. It only includes whole form of the number. Then after next one is an rational numbers. Rational numbers is denoted by the Q, means quotient. In rational numbers it includes the natural numbers, whole numbers, integer numbers and decimal numbers, or we can say that the fraction number like 5 upon 3, 7 upon 2, etc. And then after is an real number. Real number includes the all of the numbers which we can see in that square box. Real number can include the also an irrational numbers. We will discuss about the real number and irrational numbers in class 9. Here only we will discuss about the rational numbers, that mean only this of the circle. So let's start rational numbers. In this chapter we will perform an arithmetic operation on the rational numbers, and arithmetic operation of that is plus, minus, multiply and divide on different types of properties with that rational numbers. So let's start. Its first property is closure property. In closure property we will first take whole number, which includes 0, 1, 2, 3, infinite of the many of that numbers as we have discussed here. So what the closure property says is that if we add whole number, so it's with the whole number, so its answer will be in whole number. Like that 3 plus 7 become 10. SM for the subtraction also means if I subtract the whole number from the whole number, it should be a whole number. But as if we can check 7 minus 5, it becomes minus 2. So minus 2 is not a whole number. So this whole number are not closed under the subtraction. Then after is multiplication. In multiplication, that means whole number multiplied by whole number, its answer be a whole number, like 7 multiply 5 become an 35. So 35 is also an whole number. Then last one is for that is division. If whole number divided by whole number, it should be a whole number. Like if we divide 5 divided by 2, it is 2.5, or we can say 5 upon 2. So here the both type of answer are included here are not in whole form or in whole number. So this division and subtraction property cannot be satisfy the rule of the closure property. That means these whole number are not closed under the subtraction and division. Then we will check another one is an integer. So we'll perform that property again for that integer numbers. Integer numbers, that mean negative numbers, positive numbers and 0. So addition of this number, it's an integer added to the integer should be a integer. So minus 6 plus 5, it's become an minus 1. It can satisfy that rule. Another is an subtraction. Integer subtracted from the integer should be a integer. Like 7 minus 5, it's minus 2. So minus 2 is not an sorry. Next one is multiplication. Integer numbers multiplied by integer numbers should be a integer. Like minus 5 into 8, it become an minus 40. So it is an integer number, so it can satisfy that property. Another one is an division. Integer divided by integer should be a integer. So 7 divided by 2, it become an 3.5 or 7 upon 2. So these both types are not of type integer. These both type of answer are not included in the integer types of numbers. So we can say that integer not under closed of division. Then after check for the rational number. Rational numbers. So In the rational numbers, we will also perform these all operations again for the rational type of numbers. First of all, addition. Before we go through the addition, we have to clear that form of the rational number. Rational number means P upon Q type of form where Q never be a 0. So that can be a rational number. That means we can write that rational number in the form of minus 3 upon 5, 8 upon 3, 0 upon minus 7. But we cannot write any of the number in the form of 5 upon 0. That means its denominator, that means this cannot be a 0 anytime. So here is a 0, so we cannot include this in the rational numbers. So we can say that the rational number is 5, 0, minus 3, 0.5, 2.5. These all are a rational number because we can show there's all types of number in the rational form, that means P upon Q form, because 5 has no any of the denominator, so we can say here is an 1, here is also 1, and here is also 1, and 0.5 can become 1 upon 2, or 2.5 can become 5 upon 2, or it also become an 5 upon 10 or 25 upon 10, any of that form. So let's perform an operations of that numbers on rational number. First of all, we start addition for that rational number. So if we write 3 upon 8 plus minus 5 upon 7, so its answer become minus 19 upon 56. So it can satisfy that property. Same as for the subtraction also. Minus 5 upon 7 minus 2 upon 3. Its answer become minus 29 upon 21. It also can satisfy the property. Then for the multiplication. So in the multiplication also, minus 2 upon 3, 4 upon 5. It's become 6 upon 35. That means it also can satisfy the property. Then division. If we take minus 3 upon 5 divided by 2 upon 5, it's become an minus 25 upon 6. But as a rule, as a rational number, we cannot define it as a divided by 0 form. So it is not defined. So rational number are not closed under division because of this type of property. this rule cannot be satisfied. So we can say that this is not an closed under division.